Welcome to our today's session, where today we shall be having an engagement in physics. Meanwhile, before I upload the paper, then you are highly welcomed to see this unfat, the one that we shall be having Google Meet classes come December. You can share this information with a friend. You can invite him or her to this program. Then it shall be well. This is NYAGA Physics, NYAGA Secondary School. This is a school in Western. Mock examination 2025 in preparation to the KCSE 2025. This is paper 1, section 1 made of 25 marks, section 2 made of 55 marks. Then, without hesitating, we can go straight to section 1. So you are asked, the was a part of the scale of a vernier caliper are completely closed. State the zero error. So if you look at this one, the main scale, if you look at it, the main scale is reading 00, and the vernier scale, it is reading a positive number of 0.06, because if you count 1, 2, 3, 4, 5, then we are having a mark that is coinciding with the main scale, and that is mark number 6. And the moment you multiply with the least count, then it becomes 0.06. So now, since it is already reading ahead, it is already reading this value, and if you look at it, then it is on the left side of the 0 mark of the main scale. Then we say this one is a negative error. Negative error. So we are told state the 0 error. So it's supposed to be negative 0.06. This is a vernier caliper, and the units are in centimeters. You are told, question 2, explain why a body going around a circular track at constant speed is said to be accelerating. This is uniform circular motion. So you want to understand or to know why is this body said to be accelerating, yet it is moving at a constant velocity. So we have the change in the direction of the speeds at any instantaneous point. So you can say this is due to the change in direction this is supposed to be direction of speed at any instantaneous point, So that is the main issue as to why this keeps on being said that it is accelerating. Remember, the speed is constant, but the direction is the one that is changing. That is why we ought to say that this body is accelerating. We have question 3. The figure below shows a capillary tube dipped in a liquid at room temperature. Then you are told indicate on the diagram the level of the liquid in the capillary tube when the liquid is heated slightly. Explain your answer in part A. So the first thing is you need to understand that we have the forces that are bringing about the rise of this liquid in the capillary. So you can say this is the capillary. So we know that surface tension contributes to the rise. Surface tension contributes to the rise of this. And therefore, the moment you increase temperature, then you destroy or reduce, lower the surface tension. So, for this case, we expect that the liquid will slightly drop. So you can say this is now the new level. So that will be the new level after heating. Explain your answer. We can say that increase in temperature lowers the surface tension. Thus, the capillary column reduces. So you can say that increase in temperature lowers the surface tension. Hence, the capillary column lowers. Hence, the capillary column lowers. You're told that a balloon filled with helium, which is lighter than air, it is observed to rise in air up to a height of 40 meters. State the reason why the balloon stops rising. So in this case, we need to balance the forces that are acting on this balloon. The forces that are acting on this balloon. So it comes to a point where the upthrust force of the balloon equalizes the weight of helium and its fabric. So the upthrust force that is offered by the air will equalize the weight of the balloon, its fabric, plus the weight of the helium inside. Therefore, I can say the upthrust force of the balloon equalizes the weights the weight of the helium and its fabric. When we say the fabric, we mean the material making the balloon. So in short, upthrust force is equals to weight of balloon plus the weight of the helium. The weight of the balloon plus the fabric. We should be talking of the weight of the balloon. This is helium, the gas inside, plus the fabric, the material used to make the balloon. Before we move to question 5, allow me share the contacts. In case of some queries, you can reach me through 0757 01 90 11. Allow me also share this program that Ascending Grades Online School is thrilled to have you on board, that we shall be having the Google Meet classes come December, 5 weeks non-stop, where we shall be having an engagement of sciences and mathematics. You can enroll through the number on the screen. Here you meet our Hebo team that will help you keep your son busy and also help in bringing good grades. It's time for improvement because academics matters a lot. Question 5. The figure below shows temperature changes against the quantity of heat supplied to 1 kilogram each. So we're having a unit mass. We're having a unit mass, and we're having liquid A and liquid B. So this is temperature against quantity of heat. So which of the two liquids has a higher specific heat capacity? This question you need to be very careful because you must support your answer. Just don't give a random answer because it's a matter of between A and B. So if you compare these two, suppose we say we want to have a common temperature of this point of temperature X. And then now we compare the amount of heat that has been absorbed or given out. So we have like this, and the other one like this. You will find that in A, to raise that temperature to X, you require very little amount of heat. But when it comes to B, you require a lot of heat energy to rise the same temperature. Therefore, we can conclude and say B is the one with higher specific heat capacity. Then you can say that the heat required, it requires more heat energy to raise temperature. Compared to A. So that is the comparison that we have done there. We have question 6, and this one is an inclined plane under two forces as shown. Then you are asked, the toy moves upwards with a constant velocity. You must underline constant velocity. State the value of F1 given the and then give a reason for your answer. If you look at this one, it's like the body is not accelerating, but the velocity is constant. No increase, no decrease. Therefore, if we try to equalize the two forces, the 10 newtons and F1, then we shall be correct. Therefore, we can say that F1 is the same as 10 newtons. Why? The body is not accelerating. Is not accelerating. And if it is not accelerating, it's because there is no resultant force. Or you can say the resultant force the resultant force is 0. That is why it is well balanced in all corners. As you read question 7 on the screen, then allow me share the links. Allow me share the links. I think now we can continue. So we are having question 7 that is reading that a water tank with height of 3.6 meters is full of water. A thin metal plate rests flat at the bottom of the tank. If the plate has an area of 2 square centimeters, then determine the force exerted on the thin metal plate if the density of water is 1,000 kilograms per cubic meters and the atmospheric pressure is 104,000 pascals. In this case, the first thing you need to calculate is the total pressure acting on these metal plates. So, the total pressure will be the same as the pressure due to the water column in the tank plus atmospheric pressure. So this will be a height of 3.6 times density of 1,000 kilograms per cubic meters times 10. Then plus our atmospheric pressure, which is 104,000. This one will be giving us, I hope it is supposed to be 36,000 plus 104,000. This will land us to 140,000 newtons per meter squared or pascals. So the question is, now the pressure acting at the base of this tank is 140 newtons, 140,000 newtons per square meter. But we are having a small plate that is of area 2 square centimeters. So what will be the force exerted? Therefore, pressure can be given by force over area. So in this case, you want the force, which will be the same as pressure times area. Remember, in our question, the pressure that we have been given is, the area that we have been given is in square centimeters, and therefore we need to convert it into SI units so that we can work out. Therefore, our force will be given by a total pressure of 104,000 times an area of 2 square centimeters, of which this one we multiply by 10 raised to the power negative 4, so that we can convert it into square meters. Therefore, this will be times 2 times 10 raised to the power negative 4, and this will land us to 28 newtons. Sorry. This is like saying 2 square centimeters divided by 10,000. So that we get our area in meters squared. So now we can have question 8. The figure below shows a uniform ruler, can say a uniform meter rule balance at the center due to the action of some forces as shown. A is a magnet of weight 30 newtons, and B is a permanent magnet fixed on the bench. So now you are asked from the diagram, you determine the force between A and B. So now you need to assume that this part A, we award it a force X. We award it a force X. That is according to my working. But we already know that it is of 30 newtons. So we shall not use the 30 newtons in calculation. So from the principle of moments, clockwise moments is equals to anti-clockwise moments at an equilibrium. But this one in an exam, you are supposed to write in full words. Therefore, you can say that clockwise moments will be due to the 8 kilograms, and anti-clockwise moments will be due to X newtons. So the first thing, we need to convert these 8 kilograms into weight, which we shall say weight here will be mg. Therefore, it becomes 8 kilograms times 10, and this becomes 80 newtons. So now we can proceed and say that we substitute these values in this equation, where we shall say that 80 newtons times the perpendicular distance from the pivot, this one, from 75, between 75 and 50, we have a gap of 25 centimeters. 25 centimeters is equivalent to 0.25 meters, is equivalent to a force X times a perpendicular distance. If we are having this part as 10, and then the total distance from here to here is 50 centimeters, then we can say this distance here is 40 centimeters. Therefore, this will be X times 0.4. So 0.4 is 50 newtons. But the question is, determine the force between A and B. So if A is equivalent to 30 newtons, then it means that this magnet is attracted downwards to produce a total weight of 50 newtons. Therefore, the difference will be 50 minus 30, and we arrive at 20 newtons, like that. We have our question 9, which below shows two identical flasks, A, B, filled with water. Then you are told, show the levels of water, show the level of water 1 minute after the bulbs placed in between, after the bulb placed in between is switched on. We are having a bulb here. Explain your answer. So we are having a difference of the type of services here. One and B is shiny service. So what will be the difference? What will be the difference? We do know that blackened or dull absorbers of it, and at the same time they do emit it. Surfaces, they are poor, also poor emitters of it. Therefore, we can say that the blackened surfaces, the first thing is you show the level of the waters. So we expect A to rise at higher position than P. So this, and you can see the difference. Therefore, you can say blackened surfaces are good absorbers of it compared to shiny surfaces. So we expect the blackened one to absorb it very fast and then transmit that it into the liquid. We're having a question 10, but before we move to the question 10, let's have a good reminder that Ascending Grades is thrilled to have you on board. You can be having a son, you can be having a friend, daughter, or you can have somebody who is concerned with this information. Then you can share this information that we shall be having 5 constant weeks from 11th November to 12th December. We shall be offering an interactive session in sciences and mathematics. Let's boost our grades together. Meet our experts in the said categories. You can enroll, make any inquiry to our number or through the number on the screen, 0757019011. We can continue. The figure below shows unloaded spring of load supporting 300 grams. So you can say the load is of 300 grams. That is our load. So we have the spring when it is not carrying anything. Then now in our second, this is without load, with load. And then later on, when it is having a wooden block. So we are supposed to calculate the mass of the wooden block. This one has been awarded 4 marks, and the reason for the same is because you must maneuver through a certain process. So step 1, you need to get the spring constant of the spring. So number 1, you can see this is a compression. So a negative extension has no problem. We just treat it as just normal extension. So our extension 1 is the same as we say it is 12 centimeters minus 8 centimeters. We arrive at 4 centimeters. We arrive at 4 centimeters. And then our force will be the same as mg because we are having a weight of 300 grams. So from here, we convert the 300 into kilograms first, where we shall say it is 300 divided by 1,000, and then we multiply by g, which is 10. And this will lead us to 3 newtons. 3 newtons. Okay. Now from here, we can say that our K, which is spring constant, is given by force over extension. And our force here is of 3 newtons divided by our extension, which is 4 centimeters. We can work with 4 centimeters while we are knowing that it is in centimeters. So it becomes 0.75 newtons per centimeter. Remember, this one can be converted into SI units, or in SI units, it is 75 newton per meter. You multiply by 100. You multiply by 100. So that you can get it in SI units. Then from here, you look at case 2, where we shall be having this and this. So our extension 2 becomes 12 centimeters minus 10 centimeters. This gives us 2 centimeters, which is equivalent to 0.02 meters. 0.02 meters. So, since we are asked the mass, so the thing that we need to have is say that our E2 is 0. Let me get back to the one for E2 is 2 centimeters. Our K is 0.75 newtons per centimeter. Then what will be our force? So our force can be given by KE. Allow me shift this one, because I'm sure my image on the lower parts, bottom part, is likely to hinder the working. So you say equals to 0.75 times 2, and this will lead us to formation of 1.5 newtons. So now, if this one is 1.5, can treat is as the weight of the block. So mass can be given by the weight divided by G, which will be 1.5 divided by 10. And this leads us to 0.15 kg, 0.15 kg, or you can say 100 and multiplied by 1,000, 150 grams. So, or 150 grams, like that. We have question 11. Our question 11. The figure below shows an incompressible fluid flowing through a pipe A1 and A2. These A1 and A2 are cross-sectional areas of the pipes. We have the larger section and we have the smaller section, respectively. The fluid or the fluid flowing is moving with V1 and V2 as the speeds. So you can see our A1, our V1, our A2, our V2. Then you are told derive an expression for the ratio of the speeds in terms of A1 and A2. The first thing, you need to move to the equation of continuity. So that is the first step where you need to be at. That A1 V1 is equals to A2 V2. Remember, at long last, we want to arrive at V2 over V1. So you divide it through by A2 so that we can make V2 the formula. So this becomes that V2, when it is made the substitute formula, it becomes A1 V1 over area 2. Over area 2. So now let's remove the V1 on the right hand side to bring it on the left. So we divide through by V1. So V2 over V1 becomes A over area 2. Area that. And then this becomes now the equation. Apart from the base area, state any other factor that affects stability. Stability of objects apart from the base area. So we can talk of the position of the center of gravity. Don't just say center of gravity, but you need to be specific. The lower the center of gravity, higher the center of gravity, the lower the stability. We can move to section B, which is of 55 marks. We can touch some few questions where this one will be depending on the ability and the sustainability of our. So a minute. So welcome back. That we can continue. So this is section B. The figure below shows a setup in an experiment to determine the specific capacity of water. So you can look at the diagram well. Allow me to share something. So we are having that diagram over there. So we can still continue with this one. So we have this electrical method of determining the specific heat capacity. So that is as per our diagram. The first question we are being asked is about the definition part, which is define the specific heat capacity. Define the specific heat capacity. So now we can define this one as the quantity or the amount of it. The amount is the amount of it required to raise the temperature of a unit mass of substance by 1 Kelvin. So the difference between a Kelvin and the degrees is of no difference, because if you get in terms of the differences, then you'll find they are the same. If we shift 1 Kelvin ahead, then we shall also increase the degrees by 1. So they continue getting the same difference. So state 2 improvements that need to be made in the setup to obtain accurate results. Remember, in this question, we want to ensure that there is no heat loss, because there is a time in at. We don't want to have any heat loss. So what can we do so that we maintain 2 points? Number 1, insulating the container. Insulating the container with cover to minimize heat loss. And number 2, stirring the water. Stirring the water to ensure uniform heating. Ensure uniform heating. Those are the measures that you can do to improve. So now we are asked, use the above results to determine the specific heat capacity. The specific heat capacity. So what can we do? We look. So you can see we are having a voltage of a current of 1.4 amperes, total time 600 seconds, mass of water of 0.4. Then we have a change in temperature of 6 degrees Celsius. So the first thing, you analyze the question first. We can say we are having a voltage volts, a current of 1.4 amperes. We are having a time of 600 seconds. We have a mass of 0.4 kg. We have a change in temperature of 6. Then now, since this is the electrical method, you know that heat from electrical devices is given by power times time, which is VIT, is the same as the MC change in theta. So this is heat from electrical devices. So these are the other methods of getting it. So We can say that we substitute this. We have 12 volts times a current of 1.4 times time of 600 is same as a mass of water, which is 0.4 kg multiplied by a non-specific heat capacity, C, times temperature change of 6 times temperature change of 6. So the left-hand side, if you calculate without calculating even, we can make C the subject of the formula. So you divide the and by 6. So our C becomes 12 times 1.4 times 600 divided by 6. Then our C from tabulation, it comes to land at 4,200 joules per kg per Kelvin, like that. So that is our working. We have an application question where we need to pump some loads of cells, and this is question part B of the same question. Why the cooling unit, which is a freezer, inside a refrigerator is placed near the top, but an elastic in water is placed near the bottom. This one is all about to bring about convectional currents. So remember, the dense variate, the dense air, the dense water. So let's go. So for the cooling units, cooled air near the top of refrigerator move to the bottom. Since it is more dense. Warm air arises up to the cooling chamber. Okay. And this one causing convectional currents. Whereas warm water at the bottom rises up creating convectional currents. And that is why the difference in in the densities of these fluids will help bring cooling. State two factors that will lead to an increase in the rate of evaporation. Remember, evaporation takes place on the surfaces of liquids. Doesn't matter at what temperature, but it continues to evaporate. Then there are factors that will increase or accelerate the rate of evaporation. Therefore, we can give two. The one, you raise the temperature, increase temperature, then you are going to increase the rate of evaporation. Number two, if you expose a large part of surface area of the liquid, so increasing the surface area, of the liquid. And number three, in case we are having wind flow, air flowing above the liquids. And in case we lower the humidity, but now a question that is styled, state two factors, then you should only state two. The reason is because if you get the first two answers wrong, then the third and the fourth becomes correct, you will be awarded 0. If you make the first answer to be correct, the second one to be wrong, the third one to be correct, then you shall get only 1 mark. So it's good to be specific on the questions that require some specifications. A bullet of mass 24 grams traveling in a horizontal path with a velocity of 450 meters per second strikes a wooden block of mass 976 grams resting on a rough horizontal surface. After impact, the bullet and the block move together for a distance of 9 meters before coming to a rest. Name the type of collision. Remember, these two bodies will finally move together at what we call a common velocity. They are going to cling together. So this one is said to be in elastic collision. Then you are told determine the velocity of the two bodies when they start sliding, when they start moving together. So initial momentum is equal to the final momentum. So the mass of the bullets times the initial velocity of the bullets plus the mass of the block, let's say the initial of W, the mass of the wooden block times the initial velocity of the wooden block is same as they combine together M1, MB plus MW, then they move at a common velocity V. Therefore, we know that this wooden block was at stationary. Therefore, its initial velocity was 0. Therefore, this translates that the initial momentum will be 0. So, plus the mass of the bullet is 24 grams, which is equivalent to 0.0 024 times 450 plus 0 is equivalent to 976 grams plus 24 grams. This becomes, okay, we can use it 0.024 plus 0.976 into V. So this becomes 1. So 1V, or you can just say V, this is 1. V is equivalent to 0.024 times 450, and this will lead us to 10.8 meters per second. That one is going to lead us to 10.8 meters per second. It asks to determine the force that brings the two bodies to rest. Force is given by M times A. So F is given by MA. But we need to get the A first. So we can use the last equation of linear motion, where we say V squared is equals to U squared plus 2AS. We know that the body will come into rest, V we shall be 0. Our initial velocity of these two bodies, when they started moving together, we have seen it is 10.8. We have our distance S, which is 9 from the question. So you can just analyze. V will be 0. Our U here will be 10.8. Our S will be 9 meters. So you can say 0 is equivalent to 10.8 squared plus 2 times A times 9. So this becomes 0 is equals to 116.64 plus this is 18A. So this becomes negative 116.64 is equals to 18A. So our A finally becomes negative 116.64 divided by 18. And this will lead us to our acceleration being negative 6.48 meters per second squared. That is our acceleration. So now we substitute this A to this formula. So our force now becomes a mass of 1 kg, because it was 976 grams plus 24 grams. So it is 1 kg, a mass of 1 kg times negative 6.48 meters per second squared. The reason why we are still having a negative in this answer is because this is a braking force, or a force that is going to reduce our speed into 0. So it becomes a force of negative 6.48 newtons. Negative 6.48 newtons. We have an application question where you need to think critically. Part B. A missile is fired from the top of a cliff 320 meters high to a target 56 meters away. If the missile hits the target, determine the horizontal velocity of the missile. So we need to interpret this one. Like that. So we are having the height of the cliff being 320 meters. And we are having the target is 56 meters away. Then you ask, what will be the horizontal velocity? So in this case, we first get, or we can use, for us to get this height, h of 320, h will be given by half gt squared. So we can get t from this equation, since we have h, since we have g. So 320 will be the same as half times 10 times t squared. So t squared will be the same as 320 divided by 21 by 25. So this becomes 5. So 320 divided by 5 becomes 64, is equals to t squared. So at t, you get the square root, which is 8. And this is 8 seconds. So having t as 8 seconds, having t as 8 seconds, then now from the horizontal line, where we use the formula of range is given by ut, then you can get the u, which we are being as the horizontal velocity. So with r, which is 56, you can say 56 is equivalent to u, which we are looking for, times t of 8, times t of 8. So our u becomes 56 divided by 8, and this will lead us to our u being equivalent to 7 meters per second. I think we have now the last question of question 14. We're having a graph of velocity variating with time t for a body thrown vertically upwards. So the body will move upwards and finally will come down to his original place. So this is the graph. Then you ask, determine the total distance moved by the body. So our distance from this graph will be given by the area under the graph. So if you look at the graph carefully, we are having triangle 1 and we're having triangle 2. So if you get the area of triangle 1 plus the area of triangle 2, then we shall be able to arrive at the total distance of the body that it moved. From triangle 1, you can see the base is up to 2 and the height is up to 20. So we say half 2 times a height of 20 plus half times the one for this triangle 2 will be, the base will be from 2 up to 4, we have 2. Let me use a different shade. And before then, let me acknowledge Dennis Mumo. You can tap or you can indicate the school you are from or from the region you are in. For us, thank you for tuning in to us. This is the place to be, the only place where you can create an improvement in your physics grades. Dennis Mumo. Thank you. So from here up to the 4, we are having 2 units. And then from here up to here, where we're having our heights, then we are having a height of 20. So we are going to neglect the 20. We are going to neglect the 20 because it moved upwards and it came down. So it will be a half times 2 again times 20. So the total distance, this will be by 2 by 2. And so it is 20 plus 20. Meanwhile, you can have our program on the screen where we are having ascending grades on school. We shall be having Google Meet class over the December holiday. This will be pure of 5 good weeks for sciences and mathematics. Enroll now through the number you can see on the screen. You can make inquiries, you can call in time, any day, any moment. I'll be there to give any necessary assistance. Thank you so much. You can invite a friend, you can refer a friend to this channel. Now we have question 15, where we have a question on machines. Define the term efficiency. Define the term efficiency, and is the ratio of work outputs to work inputs expressed in percentage. Expressed in percentage. B. An hydraulic lift is used to raise a load of 100 kg through a height of 20 meters. Through a height of 20 meters. The radius of the effort piston is 1.6, while the load piston has a radius of 8 centimeters. If the machine is 75% efficient, calculate the velocity ratio. Velocity ratio for this part is given by the larger, that is the load piston, the cross-sectional area of the load piston over the effort, the cross-sectional area of the effort piston. But since we are having, you can say the cross-sectional areas pi r squared over pi r squared. This is for the load piston, and this is for the effort piston. But since we are having pi in common, and you can say it is r. And in this case, we shall say we have 8 squared over 1.6 squared, and this will be giving us 25 as our velocity ratio. It asks about the mechanical advantage. This one is given by the load over effort. Given by the load over effort. But since we have the load only, we don't have the efforts, then you can use the equation of the efficiency is equals to mechanical advantage over velocity ratio times the 100%. Then from where we get the mechanical advantage, okay, we can get the mechanical advantage from that part. So we know that Efficiency is given by mechanical advantage over velocity ratio times 100. So this is 75 is equals to m that we are looking for, our velocity ratio of 25 times 100. Making m the subject the formula, then we shall cross multiply and divide it through by 100. So it will be 75 times 25 divided by 100. And in this case, we shall land as a figure of 18.75. A figure of 18.75. But Roman 3 of B, the effort required. Mechanical advantage is given by the load over effort. Since now we have the mechanical advantage, we have the load. Now you can find we can find the effort. So you can say 18.75 is equivalent. The load of 100 kg from the question is of 100 kg from the question. So you convert this one into newtons because we express load in SI unit of newtons. So this becomes 100 times 10. This goes to 1,000 newtons, like that. Is equals to 1,000 divided by E. So our E becomes 1,000 divided by 18.75. So our efforts becomes, from calculations, it becomes 53.33. So our applied force is 53.33. Our last bit of the same question, not really the last question. Okay. You're asked about the energy wasted using the machine. You're told that it is 75%, it is 75% efficient, meaning that we have 25% as a waste. Therefore, we need to look at the work done. The work done. So since it is 75%, since it is 75% efficient, we can say that energy wasted is MS 25%. So our work done will be as of effort of 53.33 newtons times this load was moved through a height of 20 meters. So our distance became 20 meters. So this is force times distance. And this gives you 1,066.67 joules. Now we need to ask ourselves, what is 25% of this? So 25% energy wasted will be 25% times 1066.67. And this gives us 266.67 joules. We are talking of work, so it is in terms of joules. In terms of joules. Okay. A block and a tackle pulley system is used to lift a mass of 200 kg. If the machine has a velocity ratio of 5 and efficiency of 80%, then you're told sketch in the space provided below the possible arrangement of the system if provided with two block and tackle blocks, each with two pulleys. So now, since these are two blocks with two pulleys each, if you drop them without care, then they will lead you to a velocity ratio of 4 instead of 5. So now I'll give you the two options so that you can understand how you're supposed to rectify it. So the first one, I'll give the one as per our question. So now can I have the first block? The second one. Like this. So you need to be very careful. So the first one is of two pulleys. You can say we are having a small one here. It may not be that much accurate, but worry not. This is just a demonstration. So it is like this. First block, second block, each with two pulleys. Each with two pulleys. So now, where should we start our rope from? From the lower block. So my rope will move like this. From here, like that. So now, if you count this one properly, then we shall have the rope supporting. Remember, we have been told that it is lifting a mass of 200. So we are supposed to give it there kg. So this becomes the first, the second, the third, the fourth. And since this one is facing upward, it becomes of fifth. So you can say this one is correct. But now we need to look at the other one which is wrong. So this becomes, can say this is, can say this is 1, 2, 3, 4, 5. So velocity ratio is equals to 5. This one is going to lead us to a velocity ratio of 4. So if I start my rope here, and this becomes my efforts, then shall be having how many ropes supporting the load? 1, 2, 3, 4. This one is moving downwards, therefore it will not be part of the ropes that will be supporting the load. So we shall be having our 200 kg there. So this one is wrong. This one is correct. We have two questions, question 16 and 17, which are remaining. I think I can record them, then prepare them. Time has gone so much. Thank you for tuning in. May God bless you. You can always reach me through 07 57 01 90 11. Meanwhile, as we close the session, remember we're having a 5 weeks holiday engagements from our online school, 11th November to 12th December. Make any inquiry from 0757 01 90 11. May God bless you. Have a wonderful night. Bye bye.